Welcome to Alpha Numeric Tuition Centre. Do not skip the video because to understand the physics problems is very difficult. So each and every step is important. Each and every second is important. Now, in the question, the mass m before the explosion, okay, before it explodes, the velocity is 0 and it split into two masses. One is alpha m, another one is 1 minus alpha m. Let us assume after explosion the masses are traveling with the velocity v1 and v2. The total energy is given. The total energy is given as T. What to find now? The relative velocity, that is v2 minus v1, to be found. Okay, these are the given in the question. You know that momentum is nothing but mass into velocity. Momentum is mass into velocity. Okay. Now the last consideration of momentum is the momentum initial is equal to the momentum final. Initially the mass is capital M, but it is at rest, so the velocity is 0. But finally there are two masses with different velocities. So one mass is alpha m with a velocity of v1 and another mass is 1 minus alpha m with a velocity v2. Now m into 0 is 0. So alpha m v1 plus 1 minus alpha m v2. Now divide all by capital M. Now 0 is equal to alpha v1 plus 1 minus alpha v2. Okay. Now this minus of 1 minus alpha v2 is equal to alpha v1 or minus of 1 minus alpha v2 divided by alpha is equal to v1. Now this is a relation between v1 and v2. We will square it. Squaring it will minus will go as plus. So 1 minus alpha is square divided by alpha square into v2 square is equal to v1 square. Now we will discuss about the energy. Okay, the energy released by the explosion is kinetic energies. Okay, kinetic energy with the mass alpha m, the velocity v1. So with the mass 1 minus alpha m, the velocity is v2. So the general form for the kinetic energy is half mv square. Okay, so we will apply this formula for the respective masses. So half times the mass, first mass is alpha m into v1 square. Okay, v1 square. The second mass is 1 minus alpha m capital M with the velocity v2 square. The total energy is given as capital T. Okay? Of m v square of m v square equal to T. So we have applied the masses as alpha m and 1 minus alpha m. The velocities are v1 and v2. So v1 square, v2 square. Now multiplying all the terms by 2. Then you will get here 2 will get cancelled. So alpha m v1 square plus 1 minus alpha m v2 square is equal to 2t. Now divide all the terms by capital M. So here m will be cancelled. So alpha v1 square plus 1 minus alpha v2 square is equal to 2t divided by capital M. So dividing all the terms by m. Here m1 will cancel. Here also m by m will be cancelled. Here 2t by m. Now, what is v1 square here? So we will apply directly that v1 square here. So alpha into v1 square, that is 1 minus alpha square by alpha square into v2 square. So alpha into v1 square. Alpha into v1 square. This total is v1 square plus 1 minus alpha v2 square is equal to 2t by m. So here 1 alpha will cancel. So the remaining 1 alpha in the denominator. Now multiplying all by alpha. Okay. So here we multiply here alpha will get cancelled. So 1 minus alpha the whole square into v2 square plus alpha into 1 minus alpha into v2 square. Here 2 times alpha t by m. So multiply each term by alpha. Okay. Now 1 minus alpha square. Okay. So now divide all by 1 minus alpha. Okay. If you divide 1 minus alpha square by 1 minus alpha, so the remaining will be 1 minus alpha v2 square. So dividing 1 minus alpha by 1 minus alpha will cancel. The remaining will be alpha into v2 square. That is equal to, dividing 1 minus alpha, you will get 2 alpha t by 1 minus alpha m. Dividing 1 minus alpha. Okay. Now take v2 square as common. So 1 minus alpha plus alpha into v2 square. That will be 2 alpha t by 1 minus alpha into m. So the alpha plus alpha minus alpha will get cancelled. So 1 into v2 square. Therefore v2 square is equal to 2 alpha t divided by 1 minus alpha into m. This is v2 square. Okay. Therefore v2 is equal to root of 2 alpha t divided by 1 minus alpha into m. Now from the equation 1, So V1 will be, so from the equation 1, V1 will be minus of 1 minus alpha divided by alpha into V2. V2 we already found. It is root of 2 alpha t divided by 1 minus alpha into m. Okay? This is V1. Now we know V1 and V2. The relative velocity V2 minus V1 is a question. Okay? So V2 minus V1. Okay? Now V2 is root of 2 alpha t divided by 1 minus alpha m minus V1. V1 is already minus. So plus 1 minus alpha by alpha. Okay? 1 minus alpha by alpha into root of 2 alpha t by 1 minus alpha m. Okay? Now this 2 alpha t 1 minus lm, 2 alpha t 1 minus lm, you can take common. So the remaining will be 1 plus 1 minus alpha by alpha. So by taking this 2 alpha t divided by 1 minus alpha into m as a common term. Okay. Now taking LCM, this will become alpha plus 1 minus alpha by alpha into 2 alpha t divided by 1 minus alpha into m. Okay, this 2 alpha t. Okay, so alpha will get cancelled. So the remaining V2 minus V1 will be 1 by alpha into square root of 2 alpha t divided by 1 minus alpha into m. Now this 1 by alpha will go into the square root, but it will be square. So 1 by alpha square. This 1 by alpha will go inside as 1 by alpha square. If you take square root of 1 by alpha square, it will be 1 by alpha. So the remaining terms are 2 alpha t divided by 1 minus alpha into m. So for this alpha square, 1 alpha will go. Therefore, square root of 2t divided by alpha into 1 minus alpha m. This is the relative velocity. Try this question 1 or 2 times, 3 times, no problem. So you can expertise in this problem. It's very difficult problem. Lot of algebra is involved, lot of the physics involved. Okay. Now every video, so I am giving you at the end of the video, I am giving you a problem to try yourself. Okay. If possible, you try. Otherwise, wait for my next video. Thanks for watching my videos. You can ask your doubts in comments. I am here to solve all of your problems. Thanks for watching my videos.